This lesson is about how to find the surface area of cylinders. Now, a cylinder is defined as a solid with two congruent parallel bases that are circles. Notice how similar this definition is to that of a prism. A prism is a solid with two congruent parallel bases that are polygons. So the only difference is that the bases that are parallel and equal are circles now instead of polygons. So because a cylinder is essentially a prism with circle bases, you can derive or create the formula for surface area of a cylinder from that of surface area for a prism. So if we start with our equation for surface area of a prism, and then if we look at our bases, the two parallel equal sides, the bases are circles. So when I want to know the perimeter and the area of the base, I would say, well, the perimeter is the same thing as circumference. It's 2 pi r. The area of the base is pi r squared. So if I plug that in for perimeter and base, I get that the surface area formula is 2 pi r h plus 2 pi r squared. That is your official formula for surface area of a cylinder, and that is what you'll be using today. So for problems like number 1, you're going to take the radius they give you for the base, the height they give you for the whole cylinder, and plug that in. A couple notes about simplifying this. Some people will either mentally or on their paper move the pi to the end of the expression. That's a good first step. So it makes it a little bit more easy to visually see how you can multiply the chain of numbers that are next to each other in the same part of the equation. And keep in mind order of operations. You'll have to do the exponents. You'll have to square before you're allowed to times by 2. So make sure you square that before you multiply by the 2 in the same section of your equation. Now, also in terms of order of operations, make sure you get the multiplying done in each section before you do any adding. Adding's pretty near the end of order of operations. And then you could add, they both end in pi, so they're like terms, 28 pi plus 8 pi, 36 pi centimeters squared, since it's area. That's how much surface area your cylinder has, how much wrapping paper it would take to cover the whole cylinder. Go ahead and try question 2 on your own and pause the video until you're done. Go ahead and check your answer for question 2. Go ahead and try question 3 and 4 on your own. Pause the video until you're done. Check your answers on question 3 and 4. When you're done checking your answers, try questions 5 and 6 on your own. Pause the video until you're done. You'll eventually get to the point where you won't have to show quite as much work. I do still want to see the original numbers you plugged into the formula when you're working on your homework, so at least show that step on your homework. At that point, though, it's acceptable to do the rest in your head in your calculator. But make sure you show at least the first step on all your work. Now we're going to talk about the word problems you're going to see today, later on your homework. Sometimes they'll give you the surface area and they'll ask you to work backwards. So here they're telling us that the height of a cylinder is 3 times the diameter of the base. In other words, h would equal 3 times d, 3 times diameter. They tell you the surface area of the cylinder is 126 pi. And they're asking for the radius. I always like to summarize word problems on the side by listing out the data they give me and also what data they're asking for before beginning. Now, because they're telling me the surface area answer, I would next plug that into the surface area equation. I would say, well, I know the surface area is 126 pi, so I could plug that into the surface area equation. And I also know that the height is really 3 diameters, so I could replace h in that equation with 3d. Here's the problem with plugging in 3d there, though. Our goal is to solve for radius. In other words, we want the only variable left to be r for radius. If we plug in diameter, that's a second variable and it's going to make it very difficult to solve. However, we could rewrite this equation that height equals 3 diameters and say, well, one diameter is 2 radii. It takes 2 radii to make one full diameter. So I could say this is really 6 radii. And I could plug that in instead. Now everything's in terms of r, and it will be a lot easier to simplify and solve for radius. So I would simplify each section. I'd simplify this section by multiplying the normal numbers together and saying, oh, I have an r times r, so that'd be an r squared. So this section would become 12 pi r squared. And then this section, there's no like term, so it's going to stay as is. Now look at your current equation. Notice how these are like terms. 12 pi r squared plus 2 pi r squared, they have the exact same style ending. They're counting pi r squareds. Since they're like terms, you can go ahead and add them and say that's 14 pi r squared. Next, you could circle the r squared and work to get r squared by itself. So you would divide both sides by 14 pi. That gets r squared by itself, and you get 9 on the other side of your equation. To get rid of the square, you just have to square root both sides of your equation. So radius would be square root of 9 is 3 feet. Don't forget your units. Since surface area was feet squared, your units would be feet. Last thing for you to do today, pause the video here and try questions 8 and 9 on your own. These are to help you review what you learned last time about surface area of prisms. Begin the video again when you're done to check your answers. Go ahead and check your work. When you're done, make sure to turn in a photo of both the front and back pages of your notes on Schoology, and then you can begin the assignment. Great job today, everybody.